Hi there. This is Test Containers Live. My name is Alexa Live, and you are watching our show from the comfort of your home, hopefully. Today, we have a very nice guest in our virtual studio.
Hi.
Perfect. Hi. Hi, Sergey. I was just double checking that our audio setup is working. We are streaming, we're live, which everything works great. So today we have a very wonderful guest in our studio, Sergey Chernov. Where are you from currently? Where are you joining us from?
From Amsterdam. So
Very nice, very nice. So Sergey works as the staff engineer at Miro, which is a product company, and I don't know if you're gonna talk about like what Miro does, but they are doing an incredible software for flowcharts and dashboards and collaborative editing of those things. Um, we use it at Atomic Jar in some capacity as well. So I have a little bit of experience there. But the topic of our conversation today is not, strictly speaking, Miro or collaborative dashboards. We're going to talk about improving Spring Boot tests efficiency. Um, so stay tuned. Sorry, how did you happen to become an expert on this topic?
so we have a pretty huge monolith application. This is a central server application. For sure, we have a bunch of microservices, but still, this is our main app. More than 50 teams work on it. So it's about 2 million lines of code. And we have a lot of developers, a lot of CI/CD builds, a lot of Maven modules, and we write integration test classes. So sooner or later, we started to face issues. So I can discuss our stack.
Yes, please.
Okay,
And
so
also, what kind of issues? But maybe
yes,
first the
so
stack.
I will talk about my stack, our stack, and we'll get to issues. So our application is based on Spring Boot. We use TestNG, Maven, and in our application we have a lot of different databases, relation databases, key value storages, cloud, message queues, and others. And for the sake of integration testing, we use test containers. So we love Spring Boot, we love test containers. Eventually, our engineers started facing issues with their tests. So tests were consuming too much resources, mostly memory. Tests taking too much time. Some tests became flaky with random out of memory. And the problem, not of the engineers, but I hope of our management, was high costs of our CI/CD cluster. And it was obvious that with growth of our project, the problem will become much more severe. So we had to do something
Right.
there.
We are still talking about that monolith application, right?
Yes.
Okay, so it's a one repository, and there are just a ton of code in there.
Yes, the problem that we will discuss, they are more about monolith applications, because in monolith applications you have many scenarios. Usually in the microservice, you have a limited functionality. The domain is not that big, but for monolith application, it can be an issue.
Right.
Yes.
Okay. Yeah. This is good.
So some limitations for our solution, just worth to mention that our teams are working independently. It means that if we would choose some approach, we cannot control all the teams. We cannot review all pull requests if some guidelines are followed. So it should be something that can be called natural and reproducible and clear. It should be based on traditional stack. So we are not company like Google which creates their own technical stack to solve their problems. We prefer to use standard solutions like Spring Boot, etc. And it should be like simple and holistic. So no special complicated instructions. It should just work the way that our engineers can focus on solving their problems in their domain. And we would like to encourage them to write integration tests and don't think too much about this technical side of things. And it should be scalable with growth of the application. It should be compatible with Spring Boot 3 and others. So we are talking about mostly the Spring. And before optimizing and suggesting options to optimize the test execution, we should understand how it's actually working. The test engine executes the suite. The suite is, talking simply, is just a list of integration test classes and their methods. So the suite is executed as a cycle. When we start some iteration with fetching the next integration test class. And for this integration test class is calculated so-called merged context configuration. This is a Spring class, and this is an aggregate that includes about a dozen of different parameters. What makes much sense here, all this information can be obtained statically. So it's annotations on the class, inherited annotations on the class, fields like mock beans, etc. So we don't need to create some context, etc. And it's a very extremely lightweight operation. And this merged context configuration becomes a key for context cache. So what is context cache? It's some static map with the key of this context configuration, and the value is according Spring context. And the logic is trivial. If there is existing Spring context, the framework takes existing context. If no, it creates and starts Spring context and puts it to the cache. Then the integration test is executed, and when the integration test is finished, the framework makes a decision. Should we close it or not? I think most of engineers who write tests with Spring Test are familiar with this annotation DirtiesContext that can define behavior before, after class or methods, but whatever. It's just something that we have out of the box. And if this annotation is present, the context is closed and evicted from the cache, and we go to the next method. So we should now discuss separately all those steps, more detailed to understand how we can optimize it. So the class that I already mentioned, this merged context configuration, analyzes annotations like active profiles, mock beans, all inherited, or property sources. So in general, it's about 10 different parameters. You can follow the link just to see more detailed explanation. But simply, it's just a pojo of those 10 parameters. A difference in any of these parameters make such two configurations non-equal. So now let's consider some sample test suite that contains of 8 tests. And those 8 tests has 4 different configurations, and with the same color, we mark the same configuration. What does it mean? That if we have 4 unique configurations, Spring will create 4 separate Spring contexts for them. So as many unique configurations you have, so more independent Spring context you will have. And all those configurations as a key match Spring context, and we use the default context cache for this. By default, this cache is least recently used cache with size of 32, and what we have like out of the box with the framework, we can make it either too small or either too big. If we will make it either too small, then it will lead to more frequent redundant reinitialization of the Spring context, because it will be like evicted. If the cache will become too big, it can lead to redundant memory consumption, because if we are talking about test containers, such contexts will have beans that wrap, for example, database Postgres containers, and such contexts can be extremely heavyweight. So we will just finish with out of memory. Also, it was about the memory, but also it's worth to mention about the time. So I think for most of integration tests, there is a problem that test execution is much more smaller time value in comparison with all other time that is used to bootstrap a new Spring context. Even if there is a so-called warm start when all classes are loaded, it still can take a lot of time. For sure, this can vary, but more or less, the difference is still huge. So what does it mean? If for some reason we create and start the Spring context, we should try to use it as many times as possible instead of have more independent Spring contexts if it's possible. So out of the box, we have standard DirtiesContext annotation, and from its definition, it was created for cases when integration tests changes the shared bin state. So for example, you have two integration test classes, and one makes the state that can affect another test. And to avoid such conflict, the test is annotated with DirtiesContext, and Spring will just close it. Again, what we have out of the box here, we can never use this annotation. We can always use this annotation or define on particular classes. So if we never use this DirtiesContext annotation, all those Spring contexts will be closed when the JVM will do a shutdown. But at this moment, we can have a lot of active contexts. If we define DirtiesContext always, for example, on our base integration test class, it will again just lead to very frequent creation of new contexts, and it will take more time. Regarding particular, what does it mean? For example, you know that this context, this configuration is never used in other Spring integration tests. You mark the test with DirtiesContext to close it. But you never know what will happen later. For example, if some test will use the same configuration for some reason, like maybe it was copied, it would not reuse existing context. It will bootstrap its own. So it's not a good idea to define it this way. The most classic approach to unify Spring configurations just to reduce the number of independent configuration is to introduce some basic superclass. So integration tasks should not be independent, but if they will have some common class that defines all needed configurations, even mock beans and others, and so its subclasses will only define test methods and before methods, but no custom configurations and other customizers. This can work pretty efficient. So this is one of the most simple and classic and recommended approaches, and I think it's in the list of good practices on their official documentation. So just some simple optimization related to usage of test containers here. Use your internal Docker registry, not the Docker Hub, because it will reduce the I/O operations. Also, it's recommended to use persistent CI/CD agents if possible. So this way you will reduce the time of fetching. Oleg, do I understand correctly that in test containers cloud, you can connect private VPNs, right, to access?
Yeah, yes, of course. If you
Yes, okay.
if you're using like any Docker environment test containers will sort of piggyback on your Docker configuration to be able to pull from your sort of public or authenticated registries. And of course, like locally, it will use your VPN settings on the machine or on your CI agent. And even with the Test Containers Cloud, you can configure it to use public, authenticated, but like sort of available through public internet or internal registries. So that is not a problem. Have you tried caching the Docker cache between the different builds, or do you use persistent agents? I know people very often cache, the Maven
We use
local
persistent
repository.
agents.
Okay, very good. This way you get probably Maven cache as well, like local repo.
Okay, so we continue to discuss how to bootstrap the Spring context. If you have, for example, Postgres containers, Postgres databases that you want to use in your test and you need schema, you can pre-create such images and commit them to reuse. Just know that you should not use latest tag, but instead it should be based on some hash sum of your, for example, Flyway migrations. There on the internet you can find instructions. It will be still longer than H2, but I had a question about why not like H2. If you want your integration tests that behave much more similar to your production environments, I think you should prefer your Docker, Docker containers here. So this can save a lot of time. For example, we have hundreds of migrations, and if integration test would first apply schema, this can take a lot of time. Regarding inefficient Spring configurations, there was also mock bean definition. So mock beans look very convenient thing because it's automatically a bean definition and auto-varying, but you should avoid mock bean on your integration test classes if possible, because each mock bean will create separate configuration. The only exception that can be implemented here, if your mock beans are defined on your base integration test class, and you will have a bunch of subclasses of this basic class, it will not be considered as a separate configuration. So this is a bit tricky, but it's again a popular advice. So don't overuse it, because each mock bean will trigger another Spring context creation. So we will now talk about two general ways of reducing the number of Docker containers that work in parallel. So the first is use static Docker container. So instead of defining beans per context instance, we can use some static style singletons, and it can reduce significantly the number of active containers. It will increase the number of different conflicts, because their usage will be more often, but still this approach can make sense. This is a sample configuration of such Docker container definition. So it's a lazy singleton. What I would like to highlight here, that you need to override the destroy method for such container to instruct Spring not to close it. Because if you will expose static singleton to Spring context, when the context will be closed, it will try to call close, or it will call the close method, and the object will not be able to be reused. Also, there is a recommendation that you can add shutdown hook to close your container to JVM, yes, there is a rook daemon that cares about it, but I believe that this can reduce the time and close the container a bit eagerly. It can be a few percent, but if you will scale it on large CI/CD cluster, the saved resource can be more significant.
Nice. I think there is a configuration option for Rook to include the JVM hooks as an option for a cleanup as well. So like you don't have to write it yourself. It should be somewhere in the docs, but it's a recent addition, I think.
Nice. Also, this is a placeholder about test containers reuse. This can be another way of static-like reusage, but again, they will stay alive. Maybe it's not suitable for CI/CD, so it depends.
Yes. Can I provide just the sentence of context? Right. So reusing containers like this, if you enable the property and you add the API call to with reuse true, the containers will opt out of the lifecycle cleanup. Right. And then when you start the containers with the same configuration, exactly the same configuration, right, it will be hashed, it will be checked versus reuse, and then your Java object will sort of be connected to already running container. And that allows you all kinds of optimizations, but you do opt out of the lifecycle cleanup, like completely, right? Because you want other maybe processes to connect to your reuse. So your other processes can connect to that. Your other threads can connect to that. It's an experimental feature. There are some rough edges. You can make very cool setups make work with reuse, but you have to be a little bit more of an expert for this. We are working on making it better, right? Like we are trying to make it better and figure out the use cases. So if you're using a reuse, please come talk to me. And if you want to use the reuse, but it didn't work for you, please also come talk to me. I would love to hear about your use cases. Thank you. Sorry for this little interruption.
So let's go next. So lazy init of Postgres containers. For microservices, this problem may be not that big because they usually have a single data source. But in monolith application, we have 5 to 10 different data sources only for relational databases, not talking about other things. So it makes much sense to make a lazy initialization of Postgres container. Usually how it looks like, the Postgres container is created and there is a data source object that wraps it and they are coupled. But we will discuss some alternative implementation. So I'll show it. There is one pager. So in few words, instead of wrapping as is, we will use Spring delegating data source that will do it on demand. So what does it mean? Data source object is created, it's exposed as a bin, but actually under it there is no active container. There is just a container object of test containers that doesn't have any physical container with it. And when any of data source methods are called, like get connection usually, it bootstraps it on demand. So it will start it and give the connection. So the advantage that we have that if we define in our configuration the data source, but which is actually not used in this particular test scenario, we will save resource and we will not consume more memory.
Right. Do you do that? Do you do that also for other technologies? Because you mentioned on the slide with things you use local stack and Kafka. Do you apply the lazy init to all of them? I mean, of course, the implementation would be different, but
the implementation will be different. So on the next slide, I mentioned that you can use probably the lazy annotation, but for historical reasons, I think somewhere we use static singletons, somewhere we use lazy for data sources, but I think you can always try different approaches and make calculations. Calculations we will discuss a bit later, just as a proof of the approach. Maybe it depends more on your project. So there's no silver bullet because there's always a trade-off, and we are just discussing different solutions that can be used. But yes, the lazy pattern can be used in other in Docker wrappers. So one more mistake that can happen is if you create a data source, or in this case, it's DynamoDB mapper. It's just something like JDBC template beyond the DynamoDB. If the container itself is not exposed as a bin, but only the mapper object is exposed as a bin, the close operation will not shut down the container, because the mapper that wraps it doesn't delegate the close. I mean, it doesn't have any close method, and so it doesn't delegate it. So you always should define a couple, like container object and data source or JDBC template, whatever, and the Spring will close them correctly then. So now we will talk about like a third type of optimization. This is the most, I think, efficient. So let's get back to our test suite. And as we discussed, there are 8 tests that share 4 independent configurations. So when the suite is just starting to be executed by a test engine, we know all the classes that will be executed, and we can calculate their configuration before all the tests. So what advantage it gives us? We know that which classes are last that I use the same configuration. For example, if we're talking about yellow configuration, we know that after test 7, it will not be used anymore. The same for this one. Test number 3 will create the context associated to this configuration, but on the next execution, it's not needed anymore. And actually, we can create some simple logic that will be executed before the suite. We will have like a list of tasks that are last, and then we can use, let's call it smart DirtiesContext listener that will just define, check if this test is the last in this group, the context will be closed. So this is pretty simple. Here you can see the implementation for testng. So actually what happens here, testng allows such customizations, and there is a listener. So what it does, actually we list classes, we aggregate, we calculate the configuration classes. So there is merged context configuration that I already mentioned in the beginning. All you need to know is integration test class. So this is a simple function. As an input, it has integration test class. As output, it gives configuration. You make a map of such class, and you know which class is last for this configuration. So that's simple. You can find the gist with the full implementation. So I'd like to mention that for now, there is no such implementation for GUnit 5 Jupyter, but I guess this can be done with customizations of test engine. I think it should not be a big problem.
Yeah, it sounds like something that the testing framework should provide you, like the hooks into the suite. Could maybe be if you're looking for your first open source contribution and you're using JUnit, maybe you can take a look.
Yes, if you're interested, please contact. We can discuss. And this is the second class. This is just a Spring test listener that checks if current test is the last in this group. It's mark application context dirty. So this is the same method that is used by Spring Test DirtiesContext. I mean standard DirtiesContext. Here it's conditional. So I think this is pretty simple. 2 pages. But it's not all. We can go further. Why? If we have a list of tests and we can alternate it, we can group it the way that tests that that have the same configuration will go sequentially. So here we use so-called stable sorting, so they will be sorted alphabetically in their groups. And what it actually means, at each moment we'll have 0 or 1 integration tests, active Spring context. So this significantly reduces the number of active contacts. So the implementation is also not something complicated. Again, thanks to TestNG, it allows to change it. There's simple interceptor that makes very similar things. So we just calculate those configuration, group them, and reorder. You can find the complete implementation here. Again, for Unit 5, if you are interested, we can discuss and implement this as well. So now, like proof that it makes much sense. There is a graphic. What actually it means from the left to right, there is just a timeline. From the bottom to top, there is a number of active containers. What happens here? The huge suite of integration classes is started on the laptop, and there is a script that just calculates the number of Docker containers that are active simultaneously. And the first graphic is the situation when we don't have any kind of this optimization. So actually the situation that we could have if we just did not do our optimizations. After about 30 minutes, it starts failing with out of memory. So actually it's just interrupted because all tests are failing at this moment. We have too many active contacts. Too many contacts have a lot of bins, a lot of containers, and it's still a huge number. It's about 110. But it's not possible to execute the whole suite. So the next optimization, like is a red line, it's only smart dirty. So it was the first optimization that we discussed. So when we close contacts eagerly, when we know that this configuration will not be used anymore. The yellow line is smart dirties with reordering. So when we have not more than one active Spring contacts. So you can see what's the difference here. And the and the last one is green when we mix it with lazy data sources. So obviously the square area under this line is your cost of memory because on this range, this is like time and this is a number. So you can see how big is the difference. And also what I'd like to mention that with those optimizations, it's not only less active Docker containers at the same moment, but tests executed more fast. So you see that the green line ends earlier than the red line, just because the host, Docker desktop in this case, did not consume resource to switch context between active containers. So there's win-win.
Right. So you want like 20 minutes approximately.
10
well,
maybe.
15 maybe. I don't know.
Yeah.
But like decent minutes, not seconds. Those are
Yes,
line.
yes, yes. It's very recognizable here. So
Okay, nice.
we make our tests faster, and they consume less memory, and they cost less regarding the infrastructure. Sorry. Now imagine just if we scale up this to a multi-module build. This is just a single module because you cannot calculate a multi-module build because it can vary a lot depending on just random circumstances. But for a single module, it's easy to calculate. And now imagine the huge CI/CD cluster that runs hundreds of tests per day, and it saves a lot.
Yeah, you said 600 modules.
Yes.
Yeah, and I assume
So
some of them are small, but that's a decent savings.
So there was an argue inside of the company. So which approach should we use? Should we use static binding, static singletons, or we should use this smart dirties and beans align, which life cycle is aligned to Spring context. And we had also a calculation and made the conclusion that static cache in average has more parallel active containers. Why it happens? Because imagine you have like a JVM, and once you need the container, it will stay till the end of the JVM. And opposite the approach with smart DirtiesContext, it will be closed immediately. So imagine you have a Docker container of some database that is used in 5% of your tests. So once Bootstrap, it will be alive to the very end, but this can be different. Again, maybe in your project you will have another numbers. It depends on the structure of the test. There are just some common advices. So I think this is related to any test containers practice. Use dynamic ports for embedded HTTP servers and Docker containers. It will allow you to parallelize your test executions much better. It can be maybe not that convenient on the first time, but once you will configure it, you will achieve good results. So about adoption of this approach, I mentioned that we try to simplify the adoption of the solution, and in our case, it's pretty simple. We just define the base test class that defines the listener, and it's a super class for all of our integration tests. And why this approach is also good, most probably that any engineer that would like to write a new integration test, what they will do, they will copy existing, and this is like self-reproducible approach. So, and if we're talking about test-ng, we just define like a listener in meta information. So that's it. It just works out of the box. Even if you just have experience in Spring Test, you don't need to know such details. The only one contract is to use this class. In the worst case, if you don't use this class, you will just not have this optimization. So nothing bad will happen. There was a question when we discussed this: are tests executed like in parallel or sequential? So to answer this, we should understand how Maven is working, or Gradle. In our case, it was Maven. First, Maven tries to gather all the dependencies in compile scope, test scope, provided scope, and when they are resolved, it starts building sequentially their steps, like compile, test execute, verify. And what does it mean? If you will decompose your modules to smaller ones, and you will reduce the number of dependencies. So, for example, we have API modules, we call it contracts, and implementation modules. You will have modules with much less dependencies. It means that they can be built earlier. If they are built earlier, all modules that depend on them will be built earlier as well. Also, you can leverage the multi-core platforms. I mean, your laptops usually have 8 to 16 cores, and they can efficiently execute parallel operations, the same on CI/CD. So if you will decompose your larger modules to smaller ones, you can execute it much faster. Just take care about the number of parallel modules, because again, it can start consuming just a lot of memory. For Maven, you can, there's option that is not default. So you can just specify that the number of parallel processes should be defined via the number of cores. In Gradle, it works out of the box, but in Maven, but it works only if you have a multi-module Maven project. If you have single module, it will not have any difference. There is another approach about test distribution. So there are, worth to mention that there are tools like Gradle, Enterprise, and other that can do automatic test distributions. But you can do it also with your own infrastructure. Just define some wildcards. The only one problem that you should take care not to have tests that are not covered by any parallel steps, but this way you can just parallelize your test execution to several processes. It will require more machines, but the total time will be less. For many cases, it can be critical. So such advice. Also, there is predictive text selection. Again, it will usually require some additional tooling. So in many cases, it doesn't make sense to execute all tests. There can be local build caches or remote build caches, but again, it requires some technologies that can have paid licenses. It's up to your company to make a decision if it's worth or not, but it can save a lot. In our presentation, we discussed like the worst case when you need for some reason to execute all the tests. So this can be like complementary. For example, if you want to run such tests on your local laptop without those Gradle Enterprise features. So to summarize, I'd like to say that try to reuse the context as much as possible. Initialize late and release eagerly, and parallelize. So this way you can do much more efficient your test execution. So that's it.
Well, that was very, very interesting. I liked how we started with smaller optimizations, and then you said the best return on investment was on the sorting the test contexts to include execution. Well, it just if you sort them, there is only sort of one or maybe two sets of containers running at the same time, unless you parallelize, and then it gives you a lot of benefits for just a little input. And I also especially liked how you emphasized being a little bit of a platform team, of developer experience team. To help a developer, you need to think like a developer. When you said that we will just copy the existing test classes. So it has to work with that copy and paste solution naturally. That was very, very good. I learned quite a bit of things. I don't think we can use it in the test containers Java test suite because we are not related. We are not a Spring application. But I think maybe some of the tests, some of the approaches could be repurposed to other projects as well. So we will see. And I think just a little plug, if you are interested in Gradle Enterprise or the recently renamed to Develocity and the impact that could have, I think recently there was a presentation available online to the Developer Productivity Summit where Netflix engineers were talking about how they use Develocity and Test Containers Cloud to efficiently parallelize and scale their test distributions. So this could be like a good follow-up video if you're still watching this video after. But yeah, all in all, I think this was an absolutely incredible, entertaining, insightful presentation. Thank you so much.
Thanks. Thanks for inviting.
Yeah, absolutely. We don't have a lot of questions in the chat, but I hope, well, it was very easy to follow, I think. So, and there are people are saying nice things from the comments. So it was good. You did very, very well. If anyone is trying to contribute this to JUnit implementations, please talk to us. You can find me. Or you can reach out to Sergey directly. He's very easily available on LinkedIn. We're gonna have the link somewhere in the descriptions. And do you think Spring Boot could introduce some of those optimizations on the framework level? Do you think that would be interesting?
That's a good question. I also was thinking why there is nothing like this out of the box. But I guess the limitation here is that like three major test engines, JUnit 4, JUnit 5, and TestNG, just doesn't have some common interface that can allow to list all tests in the suite and to alternate tests in the suite. So I think that's the reason. I'm pretty sure that they were thinking about similar things.
Right. Okay, so there is just a little bit of engineering complexity involved for creating the generic solution. Makes sense. I think it would be interesting to adopt something like this in the framework, or at least give an option to run this way. And I know, for example, other frameworks also make a little bit of effort to create singleton containers because they provide test containers integrations out of the box that will spin up containers for you. So if you need just a default configuration for, say, Postgres, you don't need to specify anything much, and your application will spin up one for yourself. And then, well, that sort of gives you the static containers for free with the framework. But with this dynamic approach, you can go in further if you want to. So very good. Thank you so much. It was wonderful. I enjoyed the session. Hopefully you enjoyed talking about the results of your work as well. I think it was incredible. And for everyone watching, subscribe to the YouTube channel. We're going to be back with more incredible videos. And see you next time. Hopefully, maybe next month. Thank you.
Bye-bye. Thank you very much.